Hello and welcome to Mrs. Ballard's class. Today we are working on topic 1.8, determining limits using the squeeze theorem. Remember, at any time you can go ahead and pause the video, or you can stop and rewind it if you need to go back as many times as you need to if I go too fast. All right, so our objectives for the day are, first of all, our essential questions of how do you apply the squeeze theorem to find a limit? And then really what the meat of this, you don't see the squeeze theorem very often on the AP test, although however, they have started sneaking it in to free response questions in the past few years, so we don't want to totally skip it. But the reason we use the squeeze theorem is it gives us how we do some special trig functions, special limits of trig functions. So how do you use a special trigonometric function to find a limit? So you want to be able to, I can apply, oh, that's typed a couple times. I can apply the squeeze theorem to find a limit, and I can find the limit of a special trigonometric function. All right. Oops, sorry. Okay, let's take a look at this together. And I totally picked that a Bitmoji on purpose because this is one that makes you think. It's not necessarily the funnest or easiest. I'm going to try to make it as painless as possible for the squeeze theorem part of it. Or don't forget, again, you always write your name on here. Okay. So the squeeze theorem. So I'm going to read through the theorem and then I'm going to explain it with the picture. Okay. So if we have a function, basically if we have this function f and it's between two functions h and g, that's the fancy math way of writing that. So it's between those two functions. For all x in the open interval containing c, except it possibly at c itself, then we know that, and I think there might be a typo in here. No, it's not. Okay. Then we know that if we find the limit of the h function and we find the limit of the g function, and those two limits are the same, then the limit of the f of x function exists and it is equal to that L. Okay. So really what they're saying is I have this function f, and it's crazy looking. There's no way I could find the limit of it. So, but I could find two other functions maybe that surround it that I easily know the limit of. So if I could find a function on the top and a function on the bottom where all these values are above it and all these values are below it, once I find those two limits, I'm squeezing this function in between them. And as long as their limits match in that one spot, we know that the limit of that h or that f function in between would have to be equal to those limits. All right, so some special trig limits. So I'm just going to give you these. We could prove them. If you want to prove them, you go for it. There is where to get it. Scan those codes and go for the proof. It's with the squeeze theorem, but I'm just going to give you what the limits are. Okay, so sine, if you find the limit as x approaches 0 of sine x over x, we know we couldn't substitute that 0 in because it gives us a 0 in the denominator, but it actually, when we use the squeeze theorem on it, it actually is equal to 1. And that same is true if I flip the reverse of it. It's also equal to 1. And then this one, what you have to be careful of on this though is that whatever is here is inside here. So if I have a sine of 2x, I can't just have an x in the bottom for that to be true. I have to have a 2x. So that's going to come up here in a little bit. We've got 1 minus cosine x over x is equal to, that's actually equal to 0. And I'm not sure, I might have a typo here. I'm looking back at my notes and I'm not sure if it's that or if it's this. So I think it's probably supposed to be this, and I may retype it in your notes, and that is also equal to 0 as well. Okay. All right, so we're going to start with these trig limits, and then we'll do a little bit of squeeze theorem towards the end here. So if I have the limit as x approaches 0 of sine 4x over x, I can't just, it was too simple to give you sine x over x. You get the answer. We have to have those values match. So what I'm going to have to do is get that same value on the top and the bottom. Well, the only way I'm allowed to change a function is if I multiply by 1 or I add 0. So I'm going to pick a 1 value. So I'm going to pick a value of 1 that's helpful to me. Well, I know I need a 4 in the bottom. So that means I got to have a 4 on the top. So I'm going to multiply top and bottom by 4. It gives me the limit as x approaches 0. I'm going to manipulate it a little bit, move it around, of 4 times sine of 4x over 4x. I know now that this part here is equivalent to 1. So I know that I really just have 4 times 1, or my limit is 4. All right, I'm going to try that same thing here. So I've got the limit as x approaches 0, and I've got a 5x over the sine of 3x. Well, I have the x, but it'd be super handy if I had a 3. So again, I need to multiply top and bottom by 1, which is 3. So 3 over 3. I'm going to manipulate it a little bit, move it around. So I'm going to keep the 5 out here. I'm going to put the 3x together. I'm going to keep the 3 out in front, and I'm going to put the sine of 3x there. Same thing, doesn't matter where I put it, multiplication's commutative. All right, this here we know goes to 1. So I've got 5/3 times 1, which means my limit is just 5/3. All right, we're getting a little bit trickier because now I've got tangent of x over x. Well, I don't have any of these special things for tangent, but I do know, based on my trig identities, that tangent is the same as sine x over cosine x, and then all over x. So let's see what I can do with that. Remember, this is like saying x over 1, so I'm going to manipulate that, and I'm going to multiply by the reciprocal here. So the limit as x approaches 0 of sine x over cosine x times 1 over x. I'm going to move that around a little bit and see what happens, okay? So I've got the limit as x approaches 0 of sine x over x times 1 over cosine x. That looks a lot better, doesn't it? Because now I know that that one goes to 1. And then I'm just going to substitute the 0 in now for the cosine. So I'm going to move this up a little bit. So I'm substituting in my 0. So 1 over cosine of 0. Got to get out my unit circle. My 0 radians is here. I'm out 1 up 0. Cosine of 0 is 1. So we've got 1 over 1, or just 1. All right, this is another one of my special ones right here. This 1 minus cosine x. If I wrote it a little differently, limit as x approaches 0, 5 times 1 minus cosine x over x. The sine x over x comes up a lot. This one does not come up nearly as much, but I do recognize it, so I know that that part goes to 0. So I'm going to take 5 times 0, or just 0 for that limit. All right, I'm looking at example 5. I know I can't put 0 in the denominator because it would make it an undefined denominator. I see a squared, and I kind of see some of the parts I need, so I'm going to try splitting up that squared. So the limit as x approaches 0 of sine x over x times 1 minus cosine x over x. So I split it up. I know that this limit goes to 1, and I know that limit goes to 0. So I've got 1 times 0, or 0. All right, let's look at example 6. There's a couple of ways I could think about example 6. I can't split up the squared on that the way we did with the x. So there's two different ways I could think about it. I'm going to show you both methods. So the first thing I could do is I could factor that. So the limit as x approaches 0, because that's just a difference of squares factoring. So I know I have the square root of 1 is 1, and the square root of cosine is squared is cosine x. I'm going to make 1 a plus and 1 a minus, and then we are over x. And I happen to know that it's this one here, when I put the over x there, that this part goes to 0. Well, then I have, and it doesn't almost matter what the other part is, I could put in the 0. So 1 plus cosine of 0 times 0. Well, it doesn't even matter because 0 times whatever number this is still going to be 0. So that's method 1. Method 2, if I used my trig identities, I know that sine squared plus cosine squared equals 1. I could move this to the other side, so sine squared equals 1 minus cosine squared. So I could substitute sine squared in for that. So the limit as x approaches 0 of sine squared x over x. Well, that's close. I'd need a squared, but I could break up that squared. So sine x times sine x over x. I know that goes to 1, so I just got sine x. So, and I'm going to plug the 0 in it for it. So 0 of sine of 0, so 0 radians is here. My sine of 0 is 0 because it's the y-coordinate. All right, we're going to shift gears a little bit. We're going to do the squeeze theorem. So I'm going to show you a couple different problems on the squeeze theorem. I will go ahead and get the calculator out here in a moment, or the Desmos out here in a moment to graph it. So in this case, they're giving you the two outer functions that you're going to squeeze in between. Okay, so and you know you're going to use the squeeze theorem. If they ask you to find the limit of something super crazy, then use the squeeze theorem. Try the squeeze theorem on it. So this was very explicit. It says use the squeeze theorem to show the limit as x approaches 0 of f of x equals 0. So we're supposed to be showing that it equals 0, proving it. So I'm going to start by setting up my function, my inequality as of my function. So I know that negative x squared is less than x squared times cosine of 10 pi x. And they did give me these outer functions, so I didn't have to guess at them. But I would think that negative x squared would be something that would be less than this, and this would be something that would be greater than it. So remember, whatever I do to the problem, I have to do the whole problem. Well, I need to figure out the limit as x approaches 0. So I'm now going to take the limit of each one of these things. So the limit as x approaches 0 of negative x squared is less than the limit as x approaches 0 of x squared cosine of 10 pi x is less than the limit as x approaches 0 of x squared. Okay, I'm going to direct substitute in. I put 0 into that, I get 0. As x approaches 0 of x squared cosine of 10 pi x. And then I put 0 into this part. Oh, what do you know? I get 0. Well, if I'm squeezed between 0 and 0 on both sides, this limit overall has to be 0. So therefore, the limit as x approaches 0 of x squared cosine of 10 pi x is equal to 0. So let's actually look at a picture of this and see what's actually going on, just so you can see it because it's interesting to look at. So I'm going to go to Desmos, get rid of my old stuff. Sorry, or not. There we go. Okay. All right, so we have that. We've got h of x equals, doesn't really matter what you name them, negative x squared. Then we've got f of x equals the crazy mess x squared. Cosine of 10 pi x. Oh my goodness, look at that. Okay, and then I don't know, g of x equals x squared. Okay, so you notice how they even filled in there. And then it said to switch my window, so I can do that by the settings button over here. And it said to go -1 to 1 on both axes. 1 and -1 to 1. Okay. So you'll notice, see how it's squeezing? It's definitely squeezing it. So this function is above, this function is below, and it's squeezing it in between. So definitely there, and it looks like visually, definitely that limit is coming to 0. All right, we got one more. Oh, and you're supposed to sketch it there. So do the best you can to sketch it there. All right, I'll leave the sketching to you. Okay, so pause it and sketch it. All right, let's look at example 8 here. And we kind of have already done something like this in the last one. It's just this is phrased a little differently. So that's not a big deal. My pen. Okay, so I'm supposed to be finding the limit as x approaches 2. This definitely is, they didn't give me what f was, but they gave me two functions on either side. So I'm going to go ahead and just take the limit of those two functions. So whatever I do to one thing, I got to do to the rest. The limit as x approaches 2 of 4x minus 6 less than or equal to the limit as x approaches 2 of f of x less than or equal to the limit as x approaches 2 of x squared minus 3x plus 4. All right, I'm going to use direct substitution. There's no denominators to mess me up, so I'm going to go 4 times 2 minus 6 less than or equal to the limit as x approaches 2 of f of x. I'm going to substitute the 2 into this one, so 2 squared minus 3 times 2 plus 4. So we've got 8 minus 6, which is 2. Now let's see, 4 plus 4 is 8. Minus 6 is 2 again. So good news, we got it squeezed. So therefore, the limit as x approaches 2 of f of x equals 2. See, so not so bad. Hopefully you got the concept, okay? All right, and then that concludes our lesson for the day.